Hi there and welcome to today's lesson. In today's lesson, we're going to be working on metric and imperial conversions. And so we're going to be working on how to change what you and I maybe grew up with here in the United States to what the rest of the world uses in their metric conversions. And this is a good chance for us to really just practice the method that we learned in metric conversion. So the method is where we're going to apply the write what you're given as a fraction over 1, cancel, put the units you do want, plug in values, and continue. We're going to be doing that exact same process, but we're going to be using all sorts of different conversion factors. And the idea is that by the end of today's lecture, you should be able to convert anything. Given a conversion factor, you should be able to do those conversions without any problem at all. So the question I want you to ask yourself right now is, do I feel comfortable converting between any two units? And that's really the question I'm going to want you to ask yourself again at the end of today's lecture. And hopefully you'll be able to say, yes, I do feel comfortable converting between any two units of a conversion factor. We're first looking at the base units of the metric system. So those are the units of mass, which is grams in metric, and length, which is meters or centimeters in metric. But do you remember how we measure mass? So mass is a measure of the amount of substance. Now, unfortunately, in the secular community, the non-science community, we have replaced the term mass with weight. And that's not a standard conversion in physics or chemistry and physical science. For the purposes of our class, what you think of as being something's weight will suffice as being its mass. So the conversion factor that we're going to be using here is this one right here. 1 kilogram equals 2.2 pounds. So I'm going to go ahead and put that on the board. 1 kilogram equals 2.2 pounds. And now the idea is that once we have identified this conversion factor, we should be able to do any kind of problem that involves this conversion factor. So let's look at our first one. It says how many pounds are in 5 kilograms? And for the sake of practicing our method, we're going to go ahead and do this one together. It's asking for pounds, but it's given us kilograms. So we're going to start with what we're given as a fraction over 1. 5 kilograms as a fraction over 1. Kilograms moves down to the bottom, and the unit we do want, which in this case is pounds, goes on up to the top. So now I have canceled my units, right? What you're given as a fraction over 1, cancel the units you don't want, put the units that you do want on top, check to make sure everything's canceling out. Got it? Now I'm going to check and I'm going to plug in my conversion factor. So I'm going to come back here and I'm just going to write the value with the unit. So if it's 2.2 pounds, I just don't split that up. I say 2.2 pounds. And if it's 1 kilogram, I don't split that up. I just write 1 kilogram. And so now to plug this in to get this answer, so you should be plugging in 5 times 2.2, and I end up with 11. And the unit that I'm left with is pounds. That is equal to 11 pounds. So what I want you guys to do now is start on the next one, 130 pounds, and we're converting it to kilograms. Go ahead and work that one out, 130 pounds as you're given as a fraction over 1, and work your way to kilograms. So starting from here, you're going to take your 130 pounds as a fraction over 1. That means that pounds moved down to the next spot and kilograms came up top because this is what we want. And so now we're going to go look at our conversion factor and we're going to put our 2.2 pounds and our 1 kilogram. And this time, because the 2.2 is in the denominator, we're going to need to divide by it. So this is going to end up being 130 divided by 2.2. So when we plug that into our calculator, 130 divided by 2.2, and we get 59.090. The purposes of our class, we are just always going to go we are always going to go to 2 decimal places. So we're going to talk about rounding in a little bit. This one's hardly rounding, but 59.090. If I round that off to 2 decimal places, the 0 means my 9 stays. So that would be the answer for this question. So that's it for measuring weight. I'm not done yet. We still need to do a few more different conversion factors, but you're practicing with new conversion factors and finding that it's really just the same old story, right? Write what you're given as a fraction over 1, cancel your units down, new units on top, plug in the values for your conversion factor and multiply through. So much of chemistry is simply converting that this kind of methodology is really going to help you all throughout the semester. Okay, so here's a different one, length. So we start by putting our conversion factor for length right here on the board. 1 inch, your standard inch, 12 inches in a foot, is equal to 2.54 centimeters. So we're actually starting out with the easy one. So I want you guys to do this first one on your own, 40 centimeters to inches. So go ahead and convert 40 centimeters to inches. Start with 40 centimeters as a fraction over 1. And get the rest of the way through your problem. So at this point, we have our 40 centimeters as our fraction over 1. We've plugged in the conversion factor. So I'm going to go ahead and divide by 2.54 centimeters. Again, remember that when something's in the denominator, we have to divide by it. And I get 15.75 inches. Once again, taking my answer out to 2 decimal places, I also know 748 is the number that shows up in my calculator. So the 8 is going to make the 4 a 5. All right, so now we're ready for a challenge. I hope you're ready for a challenge. I'm ready. We are going to do a conversion between centimeters and miles. Miles to centimeters, really. So we're going to start with what we're given. We're going to do this one together. We're going to start with what we're given as a fraction over 1. So 0.0067 miles. Now, before we can really get moving on this one, we need to think, okay? We can convert inches to centimeters, but I don't know how many inches are in a mile. Do you? No. Do you know any value of something that's in a mile? What I want you to do right now is go ahead and stop, go to Google, look up how many feet are in a mile, and bring that back. You're supposed to know 5,280. 5,280 feet in a mile. This is something that a lot of people actually know off the top of their head. If you're one of them, congratulations. If you're not, I get it. I wouldn't have always known that. Okay, 5,280 feet in a mile. What else do we know? Well, we need to get to inches. I know that 1 foot has 12 inches. And so just like that, I have come up with 3 conversion factors. 1, 2, 3. And that's how many fractions I'm going to have because each conversion factor gets its own fraction. So I'm going to be making a 4 fraction problem in order to get to the number of centimeters at the end. So first I cancel miles and I put whatever I have equal to miles, whatever the second part of my conversion factor is, that's what goes on top. Then I put feet down because I want to cancel that out. And I put whatever I have equal to feet on top. And then lastly, inches cancels down and centimeters goes on top. Now I should go ahead and check my units to make sure they're canceling. So miles will cancel with miles, feet with feet, inches with inches, and I'll be left with centimeters, which is what I was asked for. So that's great news. How many centimeters? So now I'm going to go ahead and plug in. We do the same thing. We're going to keep our numeral with the unit. So 5,280 feet, because it's 5,280 feet, 1 mile. And then the next fraction, 12 inches and 1 foot. And in my last fraction, 2.54 centimeters and 1 inch. So now I'm going to go ahead and plug this into my calculator. The math on this is pretty easy because everything in the denominator is 1. So I'm just multiplying all my numerators times each other. So I start with 0.0067 times 5,280 times 12 times 2.54, and I end up with 1078.26 centimeters is the answer that I have for this problem. I hope your math went along with us.